So this is the second assignment of digital marketing analytics. And the first part focuses on the Adstock effects. So the theory behind Adstock is that the marketing exposures build awareness in the consumers' minds, so that the awareness does not disappear right away after the customer see an ad. So that is if a particular ad is aired on television in the week, in the first week, so it will have its effect not only in the first week, but it will have them in the subsequent weeks as well. So we are given a data set, which has a campaign which is promoted through TV, and the other channel used is radio. So we have the base sales and the sales with TV, and then we also have the radio sales predicted from the two different models. So therefore we have even the ad stock contributions for the four models that we have here. And subsequently we have also the insights on how much is being spent on the TV ads, and how much is being spent on the radio ads. So coming to the insights, we observe that, like, they have it makes sense to invest in TV ads as the sales are increased by some amount as compared to the without any investment. So radio advertisements did not make much impact on the sales, is what we concluded. Also, there is not much variation in the sales, in the base sales weekly, if you see through this graph. So how is the sales related to the week numbers? So we have analyzed over the 260 weeks of sales from the data given, and we can see that there is not much variation in the curve. However, we have like week 220 and week 222, which has the highest number of sales, but there is no significant gap. So now, how TV spending is affecting the sales. So now, we have introduced a new parameter, that is the percentage increase in sales over the spendings. So in this graph, you can see, like, we have different s- uh, TV ad spending amount, and then we have this represents the increase in. So this is the percentage increase in the sales due to the television ads. So we can see that as the spending starts, we can see here we have 3.5% increase, then it decreases down, and so on. So this is the quantifying factor that we have introduced for it. Also, we can notice that there is gradual decrease in sales for every particular interval. Okay. And then if there are any ad stock effects for TV ad spending, so yes, we are seeing a lot of ad stock effects on the TV ad spending. So if you see in this graph, as we are spending this much amount, so according to the model one, the ad stock value goes up to 1.2, and then it decreases, and then it increases, and so on. So we can see that the effect of this effect is observed in the subsequent weeks also, where there is no spending on the ads. So, and then how does the radio spending affect the sales? So now, here what we have done is that we have the sales for TV and radio as well. So we subtracted them from the TV sales, and we got this difference. So we can see that there is less difference compared to the weeks that we have. So in the sales, we can see that there is a difference of maximum of 21. So it there is this increase in the sales, but there is not a significant amount that the radio is contributing towards the sales. And about the ad stock effects, we can see that the ad stock effects are basically only due to the TV spendings, and we can see how we have spent on radio, but there has no ad stock effects associated with it. And coming towards the dashboard, so this is the dashboard we have, and we can see the sum of the sales is 2,86,000, and due to the television it's 2,87,000, and due to television and radio it's 2,88,000. So a less is being added by radio in this sense. So if you see over the weeks, it's usually flat, but it keeps on fluctuating around the different weeks. So we have every amount of sales that is so we have the base sales, we have the TV radio, and the TV sales also from the two ad stock models. And also now if you see the increase in sales due to TV ads and its ad stock effects, so we can see that as our spending goes on from 400, so we can see that there is a percentage increase in the number of sales. So you can see this how the sales are affected due to promotion on TV channels. And coming to the ad stock effects also, we can see how these ads attribution values uh, are being added with the different spendings that we have here. And then the change in sales due to radio spends. So we can see how this is varying with respect to the zero axis line. And again, for the ad stock effects for radio spending, we do not have a lot of effects for radio spending. So this is it for the first part of the assignment. So the second part of assignment focuses on attribution modeling and budget optimization. So marketers usually use multiple channels such as sponsored search, display ads, and emails to reach out to their customers. And each channel has various activities, and there are different costs associated with it. So in this way, there are different attribution models that exist, and each attribution model predicts a different contribution value for the different campaigns. So similarly, we have Crecio's data set, which consists of 16.5 million impressions, and it basically consists of the users browsing statistics and how what were the times that he was being converted, and how many clicks were allotted for a particular campaign. So we have sampled the data using XSV for the fast processing. So so the different attribution models which we have considered are the single touch attribution model, which consists of the first touch, the last touch, which gives entire importance for the last touch point. The first touch point similarly gives more weight to the first touch point. The linear attribution gives equal weight for all the touch points that have been included in the journey. The time decay attribution again gives more weightage to the touch points which are near to the conversion time. The U-shaped will give 80% of its weightage for the endpoints, whereas the remaining 20 will be divided among the others. And then the logistic regression falls under data-driven attribution modeling. So if you see the visualizations for the different campaign IDs, we have the last touch, first touch, linear model. So we can see that the time decay performs like it contributes more than the last touch attribution. Similarly, time decay is also performing good than the U-shaped attribution. And to simulate this, we have performed this return on investment analysis for different pitch values. And we can see that the time decay model performs better or gives the more return on investment as compared to the linear as well as the U-shaped model. We can also see that the last touch attribution also returns more as compared to the linear and U-shaped. So again, if you see that the data driven logistic regression, based on the data that we have, it returns very less as compared to the four attribution models that we have. And so similarly, among the six attribution models, we find that the contribution of logistic is very less, whereas the time decay and last touch attribution seem to give the same return of investment. One thing to be noted is that the pitch value also matters a lot, because the time decay attribution seems to give higher return of investment throughout the pitch, but the linear gives more return of investments for the earlier pitches, that is for 0 and 0.5. So this is it. Thank you.